to the problems.
Yeah,
sure. Let's talk about congruent triangles. What makes one triangle congruent with another?
They all equal. They all have writing. I don't know.
Well, there's three reasons. There's three ways. One, you can have the three sides are equal. Let's say this is a 3, 4, 5 right triangle. And over here, it's a 3, 4, 5 right triangle. So if the three sides are equal, then it's congruent.
Okay.
Okay, always, no matter what. You cannot have three sides that are the same without the three angles being the same. In other words, this angle is also equal to that angle, the right angles are equal, and that angle is equal to that angle. So having three angles and three sides makes for congruency. Let's talk about that for a second, because notice that if I have three angles equal, I don't necessarily have congruency. Let's say that's 40, 50, 90, and over here that's 40, 50, 90. Well, clearly those two triangles are not congruent, right? Congruent basically means equal. Equal size, equal angles, equal sides.
Okay.
But notice that the three angles being equal to these three angles does not make for congruency. Three sides does, but three angles do not. Okay? And there's really not that many things that prove congruency. There's another one called side angle side, and another one called angle side angle, and that's really it, those three. Well, we've talked about the first one. If I have all three sides are the same, then that's congruent. Well, let's talk about the second one, side angle side. Let's say I know that's 3, that's 4, and I know that angle. Well, if I have another triangle that has that same angle, and that's 3 and that's 4, you see what side angle side means? They have to be in a row. In other words, I can't have that. Let me just draw this real quick. If I had that, that would not be side angle side. You see why? It's in other words, when you talk about side angle side, you're talking about in a row. Well, this is 5, and then some unknown angle, and then the known angle, and then a side. So this is actually, if I go right to left, this is side, side, angle. It's not side, angle, side. So side, side, angle does not prove congruency.
Okay.
Okay? Very, very important distinction. But the most important thing I can get you to understand at this point is why this is side angle side. In other words, you have to go in a row. In fact, let me erase that. In other words, that's one side, that's an angle, that's another side, all three of them are in a row. So on this other triangle, if I have side, angle, side, also in a row, then these two triangles are congruent.
Okay.
Okay. Now, let's talk about the third one, angle, side, angle. Let me erase this. Let's say I have a triangle like this. And I know that's 30. That side is 10. And that's 70. Okay. Notice that I have angle, side, angle in a row.
Mm-hmm.
So if I have another triangle, and the only two things I know about it are that's 10, that's 30, and that's 70, these two triangles, even though I've drawn them slightly differently, notice I've rotated the one on the right.
Mm-hmm.
Doesn't matter. This is side angle side, which is, excuse me, we're doing angle side angle. So this is angle side angle, which is 30, 10, and 70. Well, if I look at this triangle, even though it's been rotated, I still have 30, 10, 70, and I still have angle, side, angle. And all three of them are the same as the first triangle.
Okay.
Therefore, they're congruent by that. And those are the only three things that prove congruency.
Okay.
You might wonder why side angle side does not. Well, let me draw two triangles here. Going to make that angle 30. That side 10 and that side 8. Now notice that is side, side, angle. See why? It doesn't really matter which way you go. You can go counterclockwise or clockwise. In other words, I could also call this angle, side, side. But side, side, angle doesn't prove congruency, and I'll show you why. I can draw another triangle that has the same 8, 10, and 30. This is also side, side, angle. And both the sides are the same, the angle is the same, but the two triangles are not the same. So side, side, angle does not always prove congruency. It sometimes does, but it doesn't always. And you only need one case where it doesn't prove it. Whereas with angle, side, angle, or side, angle, side, you absolutely know for sure that you have two congruent triangles if you have those two situations. You can't have side, angle, side and draw two triangles that are different. It's impossible. But you can do side, side, angle like I've done here. This is side, side, angle. Now, let me just test you a little bit. What is that triangle? What do we know about it? Is it side, side, angle, angle, side, angle, 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 side, side, side? What is it?
It's angle, side, angle.
Yeah. And notice that it doesn't matter which way I go. I can go counterclockwise or clockwise. If I start there, it's angle, side, angle. And if I start with the 40 degree, it's angle, side, angle. So that's definitely angle, side, angle, and that does prove congruency. In other words, if I draw another triangle over here and I rotate it a little bit and I move it up and move it over, it doesn't matter if that side's 8, that side's 40, and that side's 50. Are these two triangles congruent?
Mm-hmm.
Because of angle, side, angle. In other words, there is no way that I can draw a triangle that has a 40-degree angle, a 50-degree angle, and a side of 8 in between them that is not the same as that triangle. It's impossible. In other words, angle, side, angle is enough. Now, let me draw another one. What is this? Of the three, side, 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 angle, side, or angle, side, angle? Which one is this?
Side, angle, side.
Okay. And again, it doesn't matter which way I go. I can go clockwise or counterclockwise. But the principle is the same. In other words, if I draw another triangle over here like that, no matter what, if that's 40, that's 6, and that's 8, well, this is the same side, angle, side as this one. Therefore, they're going to be congruent. Despite the fact that essentially the difference between the words congruent and equal, I'd be reluctant to say these two triangles are equal because they're drawn oriented differently.
Mm-hmm.
If I had a triangle like this and I drew another one exactly the same, now maybe I would say those two triangles could be equal. Okay? But so this one may be equal to that one, whereas this one is congruent to this one over here on the right. And the difference is that congruent triangles don't have to look exactly the same in space. In other words, I can rotate this, I can turn it around. As long as I have side angle side equals this side angle side, then congruency applies. And what congruency means is that they end up, all three angles are the same, all three sides are the same. In other words, if this turns out to be 50 and 90 and 10, then this has to be 50, 90, and 10. In other words, the test for congruency is all three angles have to be the same, all three sides have to be the same. But you don't always need all 6 pieces of information. In other words, if you have 3 sides that are the same, you've got congruency. There's no way to draw 2 different triangles with all 3 sides being the same. Same thing with side angle side, same thing with angle side angle. So memorize those and get used to them because those are going to be fairly important in your geometry from here on out. And only those 3. Notice that angle, angle, angle doesn't work. I can draw 3 angles the same, but the 2 triangles are similar. If I have, there's a difference between similar and congruent. Congruent means same 3 angles, same 3 sides. Similar means same 3 angles. So angle, angle, angle does prove similarity. And, you know, maybe this is a 3, 4, 5, and this is a 6, 8, 10. So when you have two triangles that are similar, they have the same three angles, but they can have three different sides. But notice the sides are proportional. In other words, this triangle over here, every side is exactly twice the triangle over there. And that's what proves similarity. And actually, similarity is a much more important topic in geometry than congruency. When you go to take your college entrance exams, whether it's the SAT or the ACT, you're going to get all kinds of questions on similarity. You're not going to get that many questions on congruency. It's just that the next topic you're going to discuss in geometry is going to be congruency. But understand that the only difference between similarity and congruency is the fact that similar triangles can be different sizes. They don't have to have the same three sides. But the sides have to be proportional. In other words, 6 is to 3 as 8 is to 4 as 10 is to 5. That's similar triangle.
Okay.
And you can also say that similar triangles can be proved with side, 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 angle, side, and angle, side, angle. But that proves congruency as well as similarity. In other words, any two triangles that are congruent are also similar. It's impossible to be congruent, which essentially means equal, without having the two triangles be similar.
Okay.
Okay. Hold on a second. Let me just grab my book on your next chapter. Well, first of all, are you comfortable with chapter 7? I'm not sure we have the same books, but chapter 7 in my book is transformations.
Yeah.
Let me bring up, I took a picture out of my book the other day, and let me see if I can find it. Let's talk about it for a moment. Yeah. All right. This is a page from the transformation chapter in geometry, which is chapter 7.
Mm-hmm.
Actually skips congruent triangles, properties of triangles, and quadrilaterals. The reason is they want to talk to you about transformations before they talk to you about congruent triangles. So let's have a look at this 21 here. Name and describe the transformation. First of all, what's happening between the blue and the red? In other words, blue is being mapped onto the red. Can you see that big enough?
Mm-hmm.
Okay. Well, how is it being mapped onto the red?
It's just flipping.
Yeah, flipping about what? What line is it flipping over the y-axis?
Yeah.
No, not quite.
Oh, it's flipping over the x-axis.
No, not that either. It's flipping over the line x equal 1. Can you see my cursor?
I can see your cursor.
Okay. If I draw a vertical line at x equals,
Oh, yeah.
you can see that every point on the blue triangle is 2 units, right?
Yeah.
And every point on the red triangle is 2 units, at least these
Mm-hmm.
main lines. So I do have a reflection going on, but it's not about the y-axis, it's about the line x equal 1. Vertical lines are x equal, horizontal lines are y equal. Well,
Mm-hmm.
this is a horizontal flip, but it's not a flip over the y-axis, it's a flip over the line x equals 1.
Mm-hmm.
What about number 22? What's happening between the blue and the red there?
It's the same as the last one.
I'm sorry, what?
It's flipping over x equals 1.
No, it's not a reflection. It looks like it could be a reflection, but is all it really is,
Is it
it's a glide.
Yeah.
By how many units?
Um,
And which way, horizontally or vertically?
um, horizontally.
Correct. So take one corner of that triangle, L. That's 4 units to the left of the y-axis. And this same point right there of the red triangle is 2 points to the right of the y-axis. So how far has this blue triangle been slided to the right?
6 times.
That's it. Okay. So, and I don't know that you can depend on the fact that in 21 that's a curved line and in 22 it's a straight line. Maybe that means something. I don't know. But you can certainly examine these triangles and realize that in 22 it's not a reflection. If it's a reflection, then angle L would have to be over here on the right.
Mm-hmm.
And it's not. In other words, if you examine these two triangles, angle L is the biggest angle. These are not even isosceles triangles. You can tell they're not because the vertex is not in the middle between L and N. If it was an isosceles triangle, the vertex would have to be right there, and it's not. It's closer to L than it is N. That makes angle L the biggest angle in the triangle, and this angle over here is the biggest angle in the triangle. So I know it hasn't been reflected over a vertical line, so it has to be a slide or just a glide, whatever they want to call it.
Mm-hmm.
Okay.
Okay.
How about isometries? Have you studied those?
Not really. Like, I know, like,
An isometry is a figure that has all the angles are the same, all the side lengths are the same.
yeah.
Is 23 an isometry?
Yes.
It is.
Yes.
These two figures are the exact same shape. As all I've done is taken that figure and moved it down and to the right. How about 24?
Yes.
How about 25?
No.
Correct, because it does not have the same 4 sides. It has the same 4 angles, it looks like, but it's not the same 4 sides.
Okay.
All right. Unfortunately, I have a 4:30, so I have to run. But I think that was probably a helpful session to you.
Yeah.
And probably next week, you'll be on congruent triangles, and we can do problems out of your book or whatever problems your teacher is giving you on congruent triangles.
Okay.
Okay?
Okay.
All right, Allie. I'll talk to you next week. You have a good week.
You too. Thank you.
Bye-bye.